All right, let's go ahead and try the warm-up question. In this one, you need to multiply f of x times g of x. Okay, so for your answer here, whenever we do any of these operations, it's a good idea to put the functions in parentheses, especially in this case, because that reminds you that you need to FOIL this out. So we do our first term, gives you negative 10x. This gives you positive 6x to the third, plus 35, and then minus 21x squared. We don't want to leave our answer just like this because it's not in order from the highest to lowest power. So we want to put that x to the third first, minus 21x squared, minus 10x plus 35. So today we're going to do some different operations. We're actually going to skip ahead in the book a little bit because I think it ties in well with what we've been doing. And we're going to talk about something called a function composition. So hopefully you've heard of this maybe at some point in your math life, a composition of two functions. When you think of a composition, think of you're sort of plugging one function into another. Plug one function into another. When you compose something, you put different things together. So in a composition, you're putting two functions sort of together. Think about it. All right, so let's go ahead and look at the notation. So these are the, this is the notation here of a composition. This F with a little O. And anybody know how to pronounce that? Try to maybe say it in your head here, how you think you pronounce that. Your teacher might have said fog or goff for this. The way that you read this is F of G. That's how it's read. F of G. This one's read G of F. So when we do this, we're going to take whatever the second function is, and we're going to plug it into the first function. So in this one, we're taking F and plug it into G. You can see the notation, how that looks there. Basically, what we're going to do is we're going to replace all x's in first function with the entire second function. I'm going to do one example of this, and then we're actually going to do most of the work in Delta Math. So let's take this example here, the same two functions that we had to start with, and let's just go ahead and evaluate this. You might see either notation if you just see f of g. It's good to maybe just go ahead and rewrite it as f of g of x, like this. So that reminds you, you're going to take all of g, so this whole function here, and we're going to plug it in to where the x is there. So when we write this out, it's going to become negative 2. And whenever you make a substitution, you always want to write parentheses. So parenthesis, we're replacing that x with 5 minus 3x squared. And then we still have the plus 7. So we kept f exactly the same, except where there was an x, we replaced it with the entire g. And then we're just going to simplify this. So we're going to distribute this through. Negative 10 plus 6x squared. And then we still got the plus 7 out here. So we're just going to rearrange and combine like terms. Put our x squareds first. Negative 10 plus 7 is minus 3. So that is our answer, f of g of x. This could also work the opposite way, g of f of x, where we would take all of f and plug it into g. Switch colors here. So in this case, we're going to take all of f and plug it into the x there in g. So it becomes 5 minus 3, parenthesis, negative 2x plus 7, quantity squared. So again, we always put parentheses where we make a substitution, and we replace this x with the entire other function. First thing that we would need to do here is actually, since the whole thing is squared, we actually need to FOIL this. So you might even want to just write it out on the side here. Negative 2x plus 7 times negative 2x plus 7. And then we do a first So it gives us 4x squared, outer is minus 14x, inner minus 14x, and last would be plus 49. So that gives us 4x squared minus 28x plus 49. We FOIL that out. So we're left with 5 minus 3 parentheses 4x squared minus 28x plus 49. We now need to distribute that 3 in, and we'll do it with the negative 3. This equals 5 minus 12x squared plus 84x, it's double negative, and then minus 147. And then lastly, we just combine our constants, this one and this one. Negative 12x squared plus 84x minus 142. So that's maybe one of the more challenging ones. You could also plug a function into itself. You could technically do f of f, and you would replace the x and f with the whole original function. We're also going to do some of these with numbers. It works the same way. I'm going to demonstrate that on Delta Math. So we'll do a couple of those with the numbers and with these functions as well. So we're going to transition over there. All right. Let's actually start with what we were just doing. All right, so here's an illustration of what you're going to be asked to do. We're going to be finding f of g in this case. Now, this one actually has two variables we're going to replace. So you might, first of all, write this if you want to as f of g of x. It's helpful to write it that way. So you can see you're going to plug all of g into f, but you got to replace this x and this x with g. So what this is going to look like is parentheses to start, negative 3x minus 2 squared minus 2 times negative 3x minus 2 minus 10. So from here we have to do a good bit of simplifying. This, again, we have to FOIL because it's the whole thing squared. You might just choose to do that off to the side. That's what I like to do so it doesn't congest things. So we write it twice and FOIL it. So we get 9x squared plus 6x plus 6x plus 4. And so that gives us 9x squared plus 12x plus 4. So that's our first term. 9x squared plus 12x plus 4. With this next one, we have to distribute through here. That gives us plus 6x plus 4 minus 10. And then from this point, we're going to just combine like terms and reorganize it. Keep the 9x squared first. We then have 12 and 6x gives us 18x. 4 and negative 10, and gives us 8 minus 10, which is negative 2. So that's going to be our final answer. And we can go ahead and type that in. And let's do one more. Another thing to note with all of these is that there's this help video option right here. So you can click on that watch help video, and that will actually give you an illustration as well. Probably very similar to what we're doing. Let's go ahead and tackle one more here. So g of f of x. In this case, we're going to plug all of f into g. So we're going to have to replace it twice in this one. So this is going to be x plus 7 squared plus 2 times x plus 7 minus 1. So we're going to write x plus 7 twice. X times x is x squared plus 7x plus 7x plus 49. So that gives us x squared plus 14x plus 49. So let's go ahead and write that below it. Hopefully you're good at foiling at this point in your life. We're going to distribute this one. We get 2x plus 14. And then we carry along that minus 1. We then just organize it, combine like terms. There's no other x squared, so we'll keep that first. 14x and 2x gives us 16x. 49, 14, and negative 1 gives us 62. Type that in. All right. So hopefully you are beginning to get the hang of it. That's all there is to it. As you can see what's happening there. Let's see if this one looks any different. Very much the same here. Let's maybe one that looks slightly different. So this one just has 1 that we're going to replace. Let's go ahead and do this one. F of g means you're going to plug g into f. Again, I like to rewrite it this way so it shows me which one I'm going to plug in. So I'm going to plug this whole one and for that x. So this just becomes parentheses always, a good idea. X squared plus 2x minus 7 plus 10. Now there's no operations to do this, so we can just drop the parentheses. And then just combine like terms, which is negative 7 and 10. This becomes x squared plus 2x plus 3. And that's all we have to do. All right, so that is function compositions. I'm going to just wait to do the numerical ones on a different video, and then you'll have an assignment for that as well. Reach out to me if you do have further questions. Good luck.